Um, Thanks. So I run a team that's done an integration with Kubeflow, and I also until recently ran a company that was a pretty heavy user of Kubeflow. So I come from a bunch of different angles. I was actually interested. I was looking at or watching the previous sort of user descriptions, and I was thinking, I'm really I think I'm probably at this point on the manager user persona, but I wish that I was like an ML engineer. So what I'm definitely not is a DevOps person. So I really kind of come to you from a machine learning background, and I really kind of struggle and get frustrated with DevOps. So my team was kind of making fun of me giving a presentation to all of you, but yet they were unwilling to come themselves and talk about the work they were doing. So I'm going to hear sort of authentic feedback from a machine learning side user. Also say that I spent the last 15 years trying to basically do what the vision of Kubeflow, like just help people train models and deploy models at lots of different companies, and then customers of my past companies. I wanted to sort of show you, from in the early days of TensorFlow, I actually built some robots in my garage and deployed TensorFlow on them. And again, this is not super impressive, but I kind of wanted to share my experience of working with TensorFlow in the early days, because Kubeflow feels like that in some ways. I was also not a systems engineer by any means, and so when systems engineering became really important to do machine learning, it's really hard for me. It's really like a big challenge. Like I was used to Python, not used to like compiling, and it doesn't really that crazy compiling things. That what is it? And it's like not anyway. It's a Google thing. I'll say I really would not have been able to use TensorFlow in the early days, except for the fact that the TensorFlow PMs were really nice, and I would like write in with questions, and they would jump on Hangouts, which I know doesn't scale, but it allowed me to make this. And so I really do think that for kind of like average users like myself, like really good community support and outreach is just like it's so critical. And I think you might not realize how kind of hard it is for people that don't have the context to kind of understand what you're doing and get started. I then wrote this article. I think really kind of, I don't know, in the early days of TensorFlow kind of helped a lot of beginners like me sort of take things and deploy them on TensorFlow. I also I started a company called Crowdflow. I became Figure 8 that many machine learning teams used to collect training data. So it's a system that augmented training data, and we were early users of Kubeflow and heavy users of Kubeflow. And I kind of wanted to show you just quickly what we were doing, but I couldn't figure out how to embed this video. But basically, what Figure 8 does is it tries to make the labeling process
9% of painstakingly difficult tasks. Figure N using needing to solution is up to 100 times faster than solutions that rely on human intelligence alone, greatly reducing the time and cost it takes to create high-quality training data from captured video. Whether you need to annotate videos to teach a self-driving car how to safely navigate on the highway, object tracking built into Figure.
So basically, it's kind of object tracking. But this really helped our team in that it allowed us to kind of basically not hire unicorns, as you put it, right? So we had a DevOps team that was responsible for sort of managing the infrastructure, and then we had a ML team that worked with them. It was actually really hard to get them to be on the same page and get the ML team to build the infrastructure get the infrastructure from the DevOps team they want to build, even in a company of about 100 people. So I would just say, Kubeflow like has its warts, and my vote is for easy onboarding. But it's been a great experience for us, and the team really likes it. And actually, I just should mention that yesterday Figure was acquired, so that feels super good. So thanks for giving us free software. We just really appreciate it. So like a month ago, about a year ago, I started weights and biases. Really just thinking that, I loved working with people doing machine learning. And I think my real interest is in sort of making really good tools, kind of visualization tools and tracking tools. And so, it's really natural for us to work with Kubeflow because, we're not like fantastic infra people, right? What we like to do is sort of build tools for the machine learning people themselves. And so, we basically have a kind of model performance tracking system. I'd say the most equivalent thing is TensorBoard. I actually think a really nice feature of Kubeflow, just again, my own personal opinion. I think the way that you can pull up TensorBoard on any run is actually incredibly valuable to a lot of the customers that we talk to. So this is one feature that we had in our product where we just let you pull up TensorBoard that we just now let you do in Kubeflow if you have Kubeflow. But anyway, it's one of these things where it's a little thing, but people would always lose their TF events files, and they'd run their own local server, and it was driving people crazy. So I'd say that's like one of these things. It's like a little thing, but I think a big selling point for a lot of the folks we talk to. But we actually have a thing that has some overlap with what TensorBoard does, but a little bit of a different take. So this is kind of what if you run your model of weights and biases, you get an interface that looks kind of like this, where you can kind of see various types of objects that you track with us. So the code basically will look like either importing WB as a Python library, and then you're basically just calling WB.log. And if you use PyTorch or TensorFlow or Keras, we do some kind of smart things to automatically track a bunch of stuff. And you can pass in sort of richer objects. So like, here Chris is building a model, and he's passing in actually a matplotlib object that we then kind of render in a clever way. And you can actually sort of look at, what this looked like at sort of every step of the training. And you can also, just like with TensorBoard, sort of plot graphs, but you can kind of explore these graphs a little bit more and sort of build more complicated visualizations if you want to. And just like TensorBoard, you can kind of visualize the training that you do. I'll say where we'd like to depart from TensorBoard a little bit is in wanting to help people track more around their training. So I was really excited to see all the work on, with TFX and metadata, and that's all stuff that we'd really like to help folks track and save. But here we're basically pulling system metrics. I mean, one of the things that we often see is that people are not continuously using their GPUs, which tends to be the most expensive resource. And so, this is pretty typical where the GPU usage is around 30%, which probably means that there's something that could be improved to make the training run faster. So again, I think for DevOps people, this stuff might feel obvious, but for a lot of machine learning teams, this stuff is like kind of daunting. It's sort of unclear to even know what they should be looking at, let alone sort of how to fix the problem. And then we also track a lot of kind of metadata and hyperparameters and kind of anything that you would need to basically reproduce the model. And so, again, one of the things we love about Kubeflow is that it's kind of putting a lot of the metadata in the structured way so that we can effortlessly save this for people and then surface it for people if they want to go back and look at what they ran. I think, though, that's kind of not the core focus. I think stuff gets a little more kind of interesting with distributed training, and so that's a place where it's kind of even unclear what's the sort of core element that you want to look at, right? Like there's sort of the individual runs on individual machines, but then there's sort of aggregate data, right? When you're running across lots of things at once, and so we try to handle that super well. So what you'll see here is basically we can set up an interface where you can actually see all the different things that happened in an individual distributed run. So typically this would be like a lot more things that are happening at once. And so one or two machines might be down. Something might be going haywire in one of your machines. So giving you kind of a single dashboard that you can look at and sort of see live or see after the fact what was happening, I think is pretty useful. And again, because Kubeflow makes kind of more assumptions than sort of raw TensorFlow, we're actually able to do smarter things to like pre-group your jobs based on the variables that we see. I think the biggest thing though, or the thing that I'm kind of most passionate about what we do is actually just keeping track of what you did, right? So, people talk about sort of model reproducibility, but I think like there's even a more sort of fundamental thing, which is like, even if you could reproduce every single run that you ever did, which is hard, I think just like finding the run that you care about, like that you ran a month ago, is actually a pretty complicated, surprisingly complicated problem. And so I'll show you, so like a real world just use case. So this is Bingbin, who's a researcher at Stanford, and she's kind of building vision models for autonomous vehicle type applications. And so this is kind of a typical interface that she gets, where she can see all the different things that she ran, but she can just tag it, right, and then go in and say, okay, I want to filter across, I want to filter to just baseline post tags, or maybe just there's a different tag that I want to see, or maybe I only want to see runs that ran for at least 1 hour. Maybe that's the only relevant tags. And then I can kind of go in and sort of look at how my models performed, or actually jump into any individual run and see exactly what happened with the same interface. And actually, if there was a TF events file passed in, we would show you, we let you pull up TensorBoard on that specific run if that's what you're used to. So then I think this is like an exciting, a little more of an exciting research area. It's sort of comparisons across experiments, and so I think it's really great that so one thing that we see that's kind of funny, but we see it all the time, right, is people doing grid search or random search, just because I think it's kind of hard to set up hyperparameter search. And so I think like having Kotib like included and easy to use is actually a really big deal, and will save a lot of compute. But I think this thing you have to kind of acknowledge when you talk about hyperparameter sweeps that I think the DevOps-oriented folks don't realize, which is that there's always kind of a human in the loop when you're doing hyperparameter search, and it always starts off clean and then gets like really messy. And that might not be true at Google if you have like infinite compute resources, but I think at almost every other company, you kind of want to reuse some of the stuff that you did in a previous sweep, just because it's so expensive and long to train this stuff. So one of the things that we've tried to do is sort of make it easy to make multiple sweeps, and then kind of include all the sweeps in sort of a single interface. So here, my friend Sean ran a job where he's actually run 8 different sweeps of sort of different lengths with different parameters. And what he can do is basically look at across all of his sweeps kind of what's happening, right? So I think from that same Vizier paper, we built a kind of parallel coordinates plot, right? So you may have seen this, but this is one of those beautiful visualizations that's actually really useful. So I'm pulling in a whole bunch of maybe too many parameters for the network here. But basically here you have a plot where every line is an individual run. And so the last column here is an output metric, validation accuracy, which is probably the thing you care about most. I put in a couple other outputs. So this is loss, right? So that's an output metric. And then the stuff before that is input metrics, right? So these are, kind of classic hyperparameters, right? Like layer size, which would be like a sort of network architecture parameter, and then learning rate and momentum, and kind of some standard hyperparameters. And so what you can do is you can basically highlight different sections of different regions of sort of variables, and sort of see what other variables correlate with that, right? So I can look across multiple dimensions and say, it's pretty clear that the things with, it's pretty clear to me the things that have, for example, high accuracy have a high momentum value, or momentum value closer to 1, right? So, what this tells me is that I probably misconfigured my hyperparameter search region, right? I should probably kind of confine, or Sean, not me, Sean should confine his momentum values to values closer to 1, which, like, if you're an expert, you might maybe know that a priori, but here you could kind of figure that out, right? So in your 9th sweep that you did, you could know that you should sort of explore certain areas and restrict your search in other areas. And actually, you can add kind of connected visualizations here. So I could say, okay, I want to look at my accuracy across runs, and maybe I should name them with a say a momentum value that I care about. And I can kind of take these connected visualizations, and I can kind of see how they look across different regions, right? So, here's kind of like lower accuracy, and you can see there's certainly less smooth learning happening, right? So, one takeaway I might have is maybe early stopping would be a thing that would kind of apply well to this situation, right? Because it seems like the things that go badly are kind of off to like a really bad start, at least in the set of sweeps that I'm looking at. And really, before you did like early stopping, you might want to sort of explore this even more. So you might say, you could go to this table and say, okay, you know what? I just want to add a filter here. I like don't care about things that didn't run for at least a minute. I mean, that's probably best practice here. I can explore this table and say, okay, what happened with the things with the lowest learning rate, and actually go in and look at them, and sure enough, it's kind of struggling here. So the idea is to sort of acknowledge that today you kind of can't set up a single hyperparameter search and just let it loose and then never have a human kind of go back to it and interpret it. Or at least that's my feeling about the state of the art today. So because the Kubeflow framework makes assumptions, we're actually able to use that and make this work much better out of the box than if you were kind of building your sort of own homebrew infrastructure. And then it's kind of one more thing that I'll say that I think is really important is sort of stable reports and collaboration. So this is another colleague of mine, Stacy, right? And she basically was doing learning across, and for the ML researchers, I think this will be like pretty familiar to you. So she's basically doing an exploration of identifying plants and animals in the iNaturalist data set. And so, she's basically just kind of starts off by taking notes for herself of, sketches of kind of what she's doing. Some of this is just running individual runs. Some of it's a hyperparameter search. She wants to put in graphs as sort of the overall things that she's finding, looking at different learning rates. And so she's able to actually pull in specific results from runs, and any of these things are clickable, right? So, I could go in and look at, one of her runs, like full data set weird error, right? I mean, this is the typical, kind of names that you get, and be like, okay, what's the weird error that might have happened here? I can also look at kind of what's happening as she, kind of goes through and tries different experiments, right? So, instead of like a research paper that she might publish that would sort of beautifully summarize all of this, this is more of like a working document that I think a company would really need to kind of pick up if she left and take over, or if someone really wanted to really reproduce her work. This would be sort of a helpful guide to not just the sort of like, that little chart in every paper with like the successful runs, but like all the unsuccessful runs that happen. I think the big opportunity that I'm really excited about is with working with Kubeflow. I think I think that Kubeflow has a chance to really solve the machine learning reproducibility crisis that Pete Worden talks about. And I think I'm just like super. So my team did an integration where we basically pull all the information that we can get. So we take the Docker digest and we take the original command and the job definition, YAML, kind of all the stuff that we can kind of save for you and attach it to every single run. And what that means is we're able to make a run that basically restores your project ID. So as long as your input data is stable and you don't have random numbers floating around, which is a big if, I realize, you're able to basically just kind of restore your project to sort of any individual data run that you had. So this is super cool. I think what's coming next for us is actually we're really excited about working with the TFX data pipelines team to kind of pull in even more information, right? So that even if your data changes, you can actually have complete reproducibility. I think that's going to be really, really good for folks. If you want to learn more, I think the best place to look is in our docs. So if you go to docs.wb.com, you'll be able to find our Kubeflow integration, and you'll be able to find example code that you can use and run. I would love it if you went in and looked at this and gave me feedback. So thank you very much.